In this video, I will explain find the Fourier transform of the trapezoidal pulse shown in the figure with the help of differentiation properties of the Fourier transform. Find the Fourier transform. Find the Fourier transform of the trapezoidal pulse shown below. And shown below and using differentiation property of the Fourier transform. Property of the Fourier transform. This is the trapezoidal pulse. X of t, here t. Minus b, minus a. Here the point here is a. A, b, 0. This is the waveform. Find out the Fourier transform by using differentiation property of the Fourier transform. Differentiation property means d of xt by dt. First differentiation, and the second differentiation d square x of t by dt square. Second differentiation. This waveform is divided into three regions. This is the region 1. Constant A is the region 2. This is the region 2. This one is a portion. This is the portion 1. Portion 1. This one is portion 2. Portion 3. Portion 3. Okay. In portion 1, this is the portion 1. The shape of the waveform is like that. This one is minus b, minus a. Here coordinates from this point to this point minus b. Here coordinates are minus b comma 0. Here a is the y-axis coordinate, and this point to this point is minus a. Here coordinates are minus a comma a. Minus b 0. Minus b 0 because there is no y coordinate here. Here intersection of x coordinate value minus a and y coordinate value is plus a. Minus a plus a. In the second portion, that is constant 1. Third portion in the portion 3. In the portion 3 of the waveform, see the waveform is like that. Coordinates are here a comma b. Here b comma 0. Here x coordinate is a and y coordinate small a and capital A. From this point to this point, A. A. This point to this point is A, x-axis, and this y coordinate is A. Here b comma 0. Here minus b comma 0 minus a comma a. First of all, find out the equations. Consider portion 1 minus b comma 0 minus small a comma capital A in small a comma capital A. This one is x1 y1 x2 y2. Y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Here y minus y1 is y minus y1 is 0, y2 is a, y1 is 0, x2 is minus a, x1 is minus b, minus of minus plus b, x minus x1 is plus b, minus of minus plus b. Here y is x of t, a by b minus a, x is t, t plus b. That is equal to a t by b minus a plus ab by b minus a. Coming to this one, second one. B comma 0, small a comma capital A. x1 y1, x2 y2. Y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Y minus y1 is 0, y2 is a, minus y1 is 0, x2 is a, small a, x1 is b, x minus x1 is b. Therefore, y is equal to a by a minus b into x minus b. Y is x of t is equal to capital A by small a minus b. X is t, t minus b. These are the two portions. This is the actual waveform. Actual waveform. This one is A. This one is minus b, minus a, b. First differentiation, dx of t by dt in that interval. Some slope is there. This is the rising value, rising function. Some slope is there. Here, so first portion, dx of t by dt is equal to differentiation of a into t by b minus a is a by b minus a is constant, dt by dt is 1, dt by dt. This is the constant differentiation, that is 0. Finally, a by b minus a. This value is minus b minus a. This value is a by b minus a. This is the rising. Constant differentiation is 0. No need to consider. Here, falling function, that is a negative slope. Here for third portion, this is the portion 3. This is the portion 3. dx of t by dt is equal to at by a minus b, that is a by a minus b dt by dt minus ab by a minus b, the differentiation is 0. That is equal to, this value is 1. This value dt by dt is 1. A by capital A by small a minus b is written as minus a by b minus a. Minus a by b minus a. Here, this portion for the first differentiation, negative falling function, the slope is negative. This is the slope. The slope negative value is minus a by b minus a. This is the first differentiation. This one is the first differentiation. Coming to the next differentiation. This one is dx is d square x of t by dt square. This is the rising constant falling. This one is falling constant, and this one is constant, and falling constant and rising. Here minus b. This value is a by b minus a. Falling rising h. The differentiation of constant is 0. Here minus a is there. Here minus a. Here minus a. Minus a by b minus a, falling. This one is falling means negative value, minus b minus a. Here this one is falling. This one is ab. Here the point is a. Minus a by b minus a. Here minus a by b minus a. Constant differentiation is 0. Here b, a rising value. 0 minus of, here 0 is there. 0 minus of minus a by b minus a, that is e plus a by b minus a. Here come to this point value minus a by b minus a minus 0. That is the reason minus a by b minus a. Here 0, reached value is 0. 0 minus of minus a by b minus a, that is a by b minus a. Therefore, this is the waveform is converted into d square x of t by dt square is equal to, amplitude value is a by b minus a into dou of t plus b. Dou of t plus b. Here minus a by b minus a. Dou of t plus a. Here minus a by b minus a. Dou of t minus a plus a by b minus a. Dou of t minus b. Shifted, right shifted and left shifted impulses. These are the right shifted and left shifted impulses. Apply Fourier transform. Fourier transform to enter the equation. D square x t by dt square is a second differentiation. That is the reason j omega whole square x of omega. A by b minus a is the common term. By using shifting property, dou of t plus b. Shifting property means any function shifted t by t minus 1 is e power minus j omega t naught x of omega. Here, this is the impulse function shifted by value is plus b, left shift. Therefore, e power plus b here means minus sign is replaced with plus j omega. Shifted value is t naught is b. And x of omega. After that, x of Fourier transform of dou of t. Fourier transform of dou of t is 1. That is 1. And a similar way, minus e power j omega a and a minus e power minus j omega a plus e power minus j omega b. By using shifting property, apply shifting property, we will get this one. Got this expression. A by e power j omega b plus e power minus j omega b. Group this one, e power j omega b plus e power minus j omega b. Numerator and denominator is multiplied with 2. Next, minus 2 into group this one, e power j omega a plus e power minus j omega a by 2. This is the j minus e power j omega a, e power minus j omega by a by 2. That is equal to a by 2, bring out 2a by b minus a. E power j omega b plus e power minus j omega b by 2 is cos omega b minus e power j omega a plus e power minus j omega a by 2 is cos omega a. J omega square is j square. J square is nothing but minus 1 minus omega square x of omega. Therefore, x of omega is equal to 2a by b minus a. Here minus sign is there. 2a by b minus a into omega square. Minus sign means here cos omega a minus cos omega b. With this, the derivation is completed. If you like this video, please subscribe the channel for further updates. Thank you.